Assalamu alaikum everyone, welcome to another video about introduction to Python. This is Puya, and in this tutorial I'm going to talk about try except. Try except is one of the most important component in Python with which we can handle different types of errors that we've got in our code. There are different sources of errors that can happen in code, and in some of them, we really don't want to crash the whole code. As you know, when we run a code, and that code, when we execute a code, and it faces an error, so it crashes the whole code. It doesn't execute the rest of the codes after that error. So sometimes we really don't want to crash the whole code, and we want to just handle that error uh, and move on to the rest of the code. That's where try except is going to help us. It provides a block of code. It provides an environment that lets us to just test our uh, codes, and if anything goes wrong, it gives us some options. It provides us some options to handle those errors. So without further ado, let's talk about try except. So in this tutorial, we're going to talk about 5 topics. The first one is we're going to introduce some error types in Python. Then we're going to talk about exception handling, and we'll see how we can raise an exception manually. Sometimes we need to raise an exception to convey a message. And at the end, we're going to see that try except can be sometimes for handling some types of errors. Try and except can be much faster than other approaches like using if statements. And at the end, we're going to implement a simple exercise. So let's talk about error types. There are like different types of errors in Python, and we can also create our own errors where we're gonna see when we talk about when we introduce OOP and classes in that sections. We'll see that we can also create our own error types, but these error types that are listed here are the main ones in Python. For example, zero division error, it is raised when the second operand of a division or a modular operand is 0. Okay, when you're dividing a number to zero, it's not possible mathematically, so Python is gonna raise zero division error as well. For example, type error, it is raised when a function or operation is applied to an object of an incorrect type. Like a previous example, you expect your user to pass in like an integer, but they pass in a string or a list or anything other than integer. In that case, you're gonna have type error. So there are several errors listed here by one of my friends, so I encourage you to at least check them once. So whenever you face them, you will understand what is going wrong with your code and what you should do to resolve that error. So the next section we're going to talk about is exception handling. Exception handling, or try except, consists of 4 main sections or 4 main blocks. The first block is called try. The try block lets you test a block of code for errors. So you've got some 10 lines of code, or I don't know, as many codes as you want. It could be function classes or whatsoever. You got these codes of yours, and you want to test it for some errors, which we talked about. In that case, you should put that code in the try block, as you can see here. And we've got another block which is called except. Except is a block for handling errors. In your try block, consider that you got a division error, zero division error, or index error, or so many other errors. In that case, the exception can, whenever an error happens, the exception can catch that error. And for handling that error, you should fill in this except block. So for example, you say, you know what, if zero division error happened, just execute this block of code. Okay, so this is about except block. About else And finally, the else block lets you execute code when there is no errors. Okay, consider that there are no errors. There are no errors in your code. And in that case, you just want to print something to tell the users, you know what, everything was good, so everything was fine, no errors happened. Or you want to log something for yourself in somewhere in a database or whatsoever. You want to log that your code or this try block executed with no errors. That's where you may want to use else. And finally is the block that lets you execute codes for cleaning up most of the times. Finally is going to be executed no matter what happens, no matter you got an error in your try block or you don't have error in your try block. So let's see an example of an error. As you can see here, this is 10 divided by 0. So definitely we're going to have 0 division error because it's not possible. Division by 0 is not possible, not mathematically, definitely not in Python as well. So when an error happens, the rest of the codes after this error are not going to be executed, like this one. Print hello world, it didn't execute in this run. So if we want to handle this error, 0 division error, we should use try block. We should use try except, and we should put those lines of code that we think that they may have there might be errors in them. As you can see here, print 10 divided by 0 is located in the try block. So here we've got an except. As we talked about, except is the block that catches the error, is the section, let's put it that way, is the section, is the statement that catches the error, and whenever it catches an error, it executes its own block of code after catching the error. So it doesn't crash the whole code, it doesn't crash the whole program, and it doesn't stop it. Just execute its own block. So here we've got 10 divided by 0 and we have 0 division error. So this except is responsible for catching only 0 division errors. And as you can see here, it is impossible is printed, or we could say this division is impossible. Division is impossible. That might be more informative. That might be more, yeah. This division is impossible, and at the end it doesn't stops the program. Okay, it doesn't like interrupt the kernel. It simply executes whatever is in the except block, and it continues to execute the rest of the code. So this is how we can handle errors. Okay, and not always we don't need to, not always we should crush the code, we should stop the code. Sometimes we just need to pass in an informative message and just go on to execute the rest of the codes. And let's see here, we've got another error here, which is we've got a list of 2 items, 1 and 2, and we want to access to item at index 12. Definitely our list has 2 items and there is no item at index 12. So in this case, it's still we're gonna get another error, which is called index error. It says that less index out of range. Definitely we want to access to an item which is out of range of this sequence or this list. So as you can see, although we've got an except here, but this except only catches the 0 division errors. So this is only responsible for 0 division errors, not for index errors. And again, although we've got a 0 division error, but because the code stopped here, because there were no except to catch this error, it again crashed here, it is stopped there, and it didn't execute this one, so this block could have catch this error. So if we want to catch other types of error, we can have as many exceptions as we want. Here I've got another index error, as you can see here, another except comes with another type of error, and whenever this error happens, this is responsible for catching that error. So here, as you can see, we've got an index error at the beginning, and you have to too many R's here. Yeah, we'll get an index error here. So the rest of the code is not going to be executed in the try block as well. You should remind this. I should remind this that the rest of the code in the try block is not going to be executed. Okay, whenever an error happens, an error is raised, and the except one of the excepts could catch that error, the rest of the code is not gonna execute it again. So as you can see, you can have as many exceptions as you want, like zero division error and index error. And at the end, again, before talking about it, it is not recommended, but sometimes you may realize it's getting so complicated, you have to have so many exceptions. In that case, before I talk about this except, in that case, if you think that your code could have so many errors, the code is problematic and you should solve the code. But sometimes you can just not specify any type of error for your except sections. If you don't specify any error, this except is gonna catch any type of errors. Doesn't matter what, it's gonna catch it. But again, I told you it's not recommended. It's better to make sure what type of errors your code might have. Because if you don't know what type of errors your code might have, it means that you don't have a complete control of your code, and you haven't implemented the unit testings and the tests of your code, and your code is not reliable, really. So it's whenever you realize that you're using this type of exceptions, it should be an alert for you that there's something wrong with your code. So let's get back to except. An except with no errors identified is gonna capture all the errors. It's gonna catch all the errors. Like this one, for example, non plus 10 is not possible to execute such a command. So this except is gonna the third except is gonna catch it. Sometimes I make it, I have a simple trick, which I go on with exception as E. What is exception? Exception is the basic exception class. We're gonna talk about class in our OP section, but exception is like a very broad category. It almost includes all type of errors. Okay, so there's like no difference, let's put it that way, between an exception section that catches exception and the exception that does not identify any type of errors. So I go on with exception as E, and I just type and I just print the type of the error and its message. By doing so, I make sure to have a good log atlas to test my code to see what types of errors it has. Let me uncomment this line so we could see what was this error about, and let me comment this to not create any confusion. So okay, I should comment this one as well. So, as you can see, this says print non plus 10. Non plus 10, it says that this is a type error. Why it is a type error? Because we want to plus two types that cannot be in the same operand. Okay, and it says it's unsupported to plus a non-type and an integer. So this is a type error. By just the simple trick, I can extract the different types of error from my code. And as you can see, we can add, after realizing what was the source of the error, we can add another except, or we can solve the code. I mean, with an if. You could You could have an if statement here. If, for example, your input is none, do not just sum these two numbers. It's possible as well. Do not plus these two numbers. It's possible as well. Yeah, for example, yeah, as I told you, you can have if a statement or other types of checking to make sure you're not adding to items that they cannot be that they have two different types. So this is one way. And again, for example, let me introduce another error here, which I want to access a variable a, which is not defined. And as you can see, I have to comment this one because it creates an error and it doesn't. It goes into this section, this except. So here, print a. It says, for example, it's a name error, and the type of this error is name error, and a is not defined. If you don't know what is name error, I think 30 errors are listed here by one of my friends. And for example, name error is here. It says raised when a variable is not found in the local or global scope. It means that it is not defined. So as you can see here, using this trick, you can realize what types of errors you've got in your code. So let's talk about else. As you remember, we said else is executed when your code, the try block, goes fine and nothing goes wrong. So here, for example, we'll get an index error, so the else section is not executed. Simple as that. But in this section, we don't have any errors, and the else section is executed. You might say, what is the difference between else and just putting this print or whatever code we've got at the end of the try block? Because else is executed when when everything went fine. Okay, so there's no difference between taking this section from S and just implementing it at the end of the try block. Yeah, it's up to you, but this functionality is provided by Python, so I'm just gonna introduce to you. I don't see this type of structure like try except else a lot. I don't remember the last time I saw in a third-party library or whatsoever, but still this is a functionality. Maybe you want to log something that, you know what, this try block went well, there were no errors, and you can trust this try block or whatsoever. As I told you, this is not the case in most business level programming. Most of the codes are unit testing, are based on unit testing. There are different tests for different parts of the code, and most of the time you don't need this kind of logging, but it is still there, and if you want to use it, you can try it. The finally section, as we talked about, the finally section is the block that is going to be executed no matter what happens, no matter your try block contains any code or it doesn't. So what do we mostly do in finally block? In finally block, most of the times we close the open files and we close the connections to databases. I mean, most of the times in that block, we clean up our RAM and our code. Because consider that you open a file here, a huge one, or you open a connection to database. So, and an error occurs and you don't have the chance to close the connection with your database, or you don't have the chance to close the file. So to unlock those files and those databases, you can put the closing section at the finally, so you make sure that even if you encountered some errors, you make sure that your finally block is gonna close those connection and it's gonna release those RAM from your RAM, those sections from your RAM, and it's gonna unlock the file. If you watched the previous video about file handling, you remember that we've got several conflicts about not closing the files. I mean, not closing the file, a file on your hard is gonna lock that file, and it's not gonna let even other users to access that. So in finally section, you can make sure that you are closing the connection to any database and any files. But again, remember, whatever is in finally, it is going to be executed no matter the try block goes fine or no matter try block encounters any kind of errors. So as you can see, whatever happens finally exists. Exactly, it exists. And again, in this section, everything is safe as it is mentioned here, which means that there are no errors in try block because else was executed, so finally was executed as well. But here we got an error which was catched by this exception, except with no errors mentioned, specified. So else was not executed, but again finally was executed. So in any case, finally is going to be executed. So raise an exception. Sometimes you want to handle your code with raise an exception. Again, in the previous example we talked about, the user passes in an integer or in an appropriate value or something. In that case, you want to just stop the code. You want to just crash the code, okay? You don't want the rest of the codes to be executed because there may, for example, create some cause some more complicated errors, and you don't want it to happen. You just want to simply stop the code, raise an error for the user, and to convey a message to the user. You know what, you made a mistake here. With this mistake we cannot run the rest of the code. It's better not to run the rest of the code, and it's better you just modify your code or modify your input or change the request you've got. For example, you want to access to an unauthorized file, so in that case you're gonna create another exception and tell the user, you know what, you don't have the authentication, you don't have the credentials, so you cannot access to those files. By all this, there are several scenarios, and by all of them, in each of them you can have your different exceptions. To raise an exception, you should use raise keyword. So far we talked about 4 keywords: try, except, else, and finally. For raising an exception, you should use this raise keyword and create this statement. And inside your error that you use, you can have your own message. It's better that your class of error and the message you want to convey to relate with each other, and we'll talk about it. Consider the user is trying to pass in a negative number, but in your program, in your rules, based on your rules, numbers below 0 or negative numbers are not allowed. So you're gonna just raise an exception. This is not, oh, I should have said not recommended. This is not recommended because the exception and the message, the exception is so broad. As we talked about, exception class is so broad. It kind of includes all types of error. It doesn't really convey a good message to user. It's better to have, in this case, it's better to have a value error. Let me say it is recommended. It's better to use value error because the type of the error is correct, is integer as you expected from your users, but its value is not correct, is not does not follow the rules of that program. So it's better to go on with value error instead of like exception error, which is so broad. So here, for again, you convey this message to your users that, you know what, number below 0 are not allowed, and you say that it's a value error. You know, the type of the input you passed in was correct, everything was correct. Just work on the value of your error, don't change the type. If you change the type, you're gonna create like a more serious problem here. We just want you to change the value of your input. This is another example. Consider that you expect your user to pass in an integer, but they pass in a string. They pass a string like this hello. And in this case, you should raise a type error, because here we're not talking. The problem is not the value. The problem is the type. The user should have passed in an integer, but they passed in a string value. So here, string value. So here you tell the guys, you tell your user, you know what, only integers are allowed. After this section, you may want to have another value error for incorrect values. So let's talk about a speed test. Speed test is my favorite. There are some cases that you got two options. Most of them you got two options: whether to handle that error, whether to prevent that error before happening using if statements. Okay, for example, the user can pass in like integer and a list. So you can have an if statement to check whether it is an integer or it is a list. If it was an integer, you are gonna execute the code. If it was a list, you can, for example, send a message to the user, you know what, you made a mistake, please pass in an integer or something like that. So you got two options. The first one is to go on with if statements, and the second one is to go on with try except. What is try except is gonna do here? Consider in the previous example, like the user should pass in an integer. If it passes a list, you're not gonna create an if statement. You're just gonna have your code considering that the user is gonna pass in an integer. No matter what, the users, they're gonna pass in integers. And if they pass other types of errors, I'm gonna catch them. You can catch them with except, and you're gonna execute your code at the exception section. So let's see an example to illustrate this issue. We got a list which consists of 1 billion items, and at the end it has two strings. So like 99%, more than 99% of the input values are correct, but only two of them are incorrect. In this case, you can have an if statement to check whether the type of the input is integer or not. If it was an integer, you may want to say, you know what, if it's not an integer, print not integer. You can go on with this. We can execute the code. Or like 1 billion times, you're executing this if statement, this condition, for 1 billion times. This statement is executed. But here, let me say, for example, not integer again here. But in this section, you have just one flow, and this flow is executed, and only in for two inputs, this exception is being catched and executed. So in this section, in this code, we've got just one flow, but in this code, we've got two flow, which is one condition and two flows because of if statement, that both of them, that condition is being executed for like 1 billionth time, more than 1 billion times. So let's use time it to see which one is faster. Definitely this one should be faster because it consists of one flow, and as you can see, it takes about 839 nanoseconds, but this one takes about 700. This is much faster compared to this one. So if sometimes you don't need to use if statement to catch the errors, different types of error, if your code, your inputs are mainly correct and there are some minor incorrect inputs to your code. In that cases, if you care about the speed, like with this small differences, you can go on with try except. It's totally okay to use try except to have a faster code. So here we've got an exercise. I think you remember this exercise from one of our, it was one of our first exercises that we had. In that example, in that exercise, it was explicitly mentioned not to use try except, but sometimes solving codes with try except is so easy because checking different scenarios, different conditions can take a lot of time, and try except can simply solve it. So what is the task? The task says we got a list of strings. In some of this strings, some of the items are a string, but they can be converted to integer. So just get the integers from the strings in your code. So we want to handle this with try except. In this case, I'm gonna create a loop item. I'm gonna call it lst item in lst. So let me print lst item. So look up lst. Oh, I didn't execute this one. lst item 11 puya 10 10.5 10 puya. So here, if I wanna create, let me create result list as well. Result. So here, if I wanna result.append, just simply converting to integer, the list items converting to integer. So I'm gonna have an error. It says a value error, invalid literal for int with base 10. So it says there is a value error here. So you know what, I'm gonna use try except, and I'm gonna tell that, you know what, just go on and catch the value errors. If you encounter value errors, just simply pass it. Does not stay, does not execute any code. Just pass it and execute the rest of the code of this for loop. And here, let me print it at the end, and let me remove this print. So as you can see, with just a simple try except, we solved this code, which I'm pretty sure that without using try except, you should have implemented different types of different lines of code to check whether each character is integer or not. But try except, as you can see, sometimes can make the code so easy and sometimes can make the code much faster. And if I want to implement this with comprehension, I should create a function like I'm gonna call it get integer, and it could have an input, for example, and here I'm gonna take the input. I'm gonna have a try. I'm gonna return integer of the input. And if it doesn't work, except value error, I'm gonna pass in like a non-value. And I can use this in my comprehension for lst item in lst. I'm gonna pass it to this function, lst item. If we do so, we're gonna have 11 non, 10 non, non, and we can have the second filter like for r in result list, and we can filter it if r is not none. This is one way we can run this result. What's wrong? Oh, return. No, this didn't return. So result lst. So we can have two comprehension, or if we want to do it in one comprehension for loop, we can just go on with this and say, you know what, execute it for the second time, and if is not none. This is in one loop, but this code is executed for 2 times. So if any of you guys have any idea to make this list comprehension for getting this integer much easier, just let me know and comment it in the comment sections. So before we leave, here in my GitHub repository, you can access to different codes and videos we talked about. For example, we talked about comprehension, and here, comprehension single line if statement, you can have access to if you're not familiar with comprehensions. For example, the pass statement that I used, we talked about it in the 18th video about functions advanced topic. You can check it. So, and I'm gonna put the link to the repository in the video's description, so you can have access to different codes and different videos from this repository as well. Like always, please consider to subscribe the channel, click on the like the video, and click on the bell ring so you would be notified of the future videos. Till the next video.